A volcano might seem like an unstoppable force of nature, but as it turns out, there is at least one other force on Earth that seems to be able to stand up to it, and that is the crushing weight of a massive glacier. Welcome to MinuteEarth. Volcanic activity seems constant on our planet, but it's really not. Relatively recently, geologically speaking, Earth went into a volcanic dry spell that lasted 100,000 years, where glaciers covered roughly a third of the Earth's surface. A glacier is the enemy of a volcano because it deprives the volcano of what it needs the most: magma. Usually, the Earth's mantle is solid thanks to the pressure exerted by the massive tectonic plates in the crust on top of it. But if the pressure is somehow released, the mantle partially melts, forming magma that gathers in chambers, rises through the crust, and then explodes as a volcano. This type of melting doesn't just happen anywhere though. It typically takes place under lighter spots in the crust, like a seam where tectonic plates are pulling away from each other. Well, except for when there's a giant glacier sitting on the seam, as was the case during the last ice age. Glaciers are so heavy that they keep the mantle under pressure even at the seams, preventing melting and thus preventing volcanoes. During the last great ice age, glaciers also stopped the other type of melting, the kind that happens where tectonic plates collide. During those collisions, one tectonic plate is shoved underneath another, and the immense pressure in the mantle literally squeezes water out of the sinking plate. That water flows into the mantle, lowering the mantle's melting point and causing magma to form. Glaciers probably didn't prevent this kind of magma from forming, but instead put so much pressure on the crust and mantle that the magma wasn't able to rise. Instead, it simply pooled in chambers and waited there until the glaciers left. And when the glaciers finally went away, the volcanoes came out to play. Estimates suggest that global eruption rates spiked to as high as 6 times above average in the few thousand years after the ice melted. In Iceland alone, 30 times as many volcanic eruptions happened in the immediate aftermath of the most recent ice age than in the entire 100,000 years before it. Of course, at some point in the future, winter will come again, and volcanoes might cease to form. It's a geologic dance to a real song of ice and fire.